Way back in 1949, mathematician
John von Neumann
postulated the idea of computer viruses. In fact, he went one step further than that and actually came up with a design for a self-replicating computer program which was published in the book Theory of Self-Reproducing Automata. To that end, he is widely considered to be the father of computer virology. The problem was, in 1949 computer systems were in their very early infancy, and neither he nor anyone else could really put this theory into practice. Indeed, it would take another 2 decades before anyone decided to do it, and just screw technology over for the sake of it.
Although the details are hazy, it's claimed one of the first instances of malicious software was at the University of Washington Computer Center in 1969. At the time, the center housed a Burroughs 5500 produced by the Detroit-based Burroughs Large System Group, a mammoth 48-bit mainframe that was state-of-the-art and actually ran off disk storage. This system was used for a variety of research and experimentation, but it was a program called Rabbits, which stepped outside the normal productive realms and instead caused a problem. Rabbit burrows, yeah, I get it. We don't know exactly who or why this program was being run, but upon each execution, Rabbits would create 2 or more instances of itself, quickly consuming all the resources of the 5500 and eventually crashing the system. Although it remained on one system and therefore couldn't be classified as a worm, nor a virus given it didn't infect other files or areas, this was actually the first instance of a fork bomb. Really a localized example of what a computer worm could do on a mass scale.
Of course, since then, computers have changed into a state of almost perpetual connection, so it's lucky we have tools like sponsor Surfshark around to protect us from the issues that causes. Surfshark is a VPN, a virtual private network, and it keeps you safe by securing and keeping all your online activities encrypted. Imagine a reinforced impenetrable tunnel between your computer and a non-logging server in any of these locations. That's what Surfshark creates, and then conducts your internet activity from the remote server. That means that anyone who tries to snoop on you can't. Anyone that tries to intercept an email through Wi-Fi cannot. It also means that services like Netflix or even hotel and travel sites think you're logging on from the country your selected server is in, allowing you to access region-exclusive content and prices. Plus, you get a lot more security to boot. Surfshark subscription allows unlimited devices, and you can get 83% off and 3 months extra free using promo code NOSTALGIANERD at the link below.
This is CoreWar. It's a programming game created in 1984 where 2 programs battle it out for complete control of a virtual computer. Each program is written in a type of assembly language called red code. You let the code run and see what plays out. It's interesting that CoreWar then is actually based on a pair of computer programs created over a decade prior, Creeper and Reaper. This really is the battle between a computer worm and an antivirus playing out in front of us, and there's only one winner. Game-wise, it's actually quite intense, with well-known strategies established. These strategies, such as Vampire or Imp, are based on programming techniques created by the likes of Xerox. But without Creeper and Reaper, these methods wouldn't exist. In fact, without Creeper and Reaper, our computing landscape would look very different indeed. Recently, I went to the Science Museum in London, an incredible destination that I recommend everyone should visit. It's hard to know where to begin with the sheer amount of technology they have on show. But I was mainly drawn by this packets of bits cross the Atlantic display. Here we have a giant hulking machine that in the early 70s sent digital information to another in California. This was the first transatlantic link, and it ran across the ARPANET computer network. That's impressive enough alone, but nestled next to it is the operator console for a digital equipment PDP-10. Now obviously this isn't the entire machine, that needed an entire room, but this little interface from the University of Hertfordshire was manufactured between 1966 and 1970 and had the capability to also connect up to the ARPANET. ARPANET may be a name resigned to the history books, but its significance is immense. Created in 1969 by the US Department of Defense, the ARPANET project was the first wide-area packet switch network with distributed control. Over in the UK we had the NPL, which although faster was less grand in scale. ARPANET consisted of around 20 sites, utilised coast-to-coast telephone lines running at 64 kilobits per second, and even had satellite links to Hawaii and London funded by the British Post Office, although the London connection could only muster 9.6 kilobits per second. It also utilised the TCP/IP protocol, the very foundation of our modern internet, but at its core was the potential ability to share data and access remote computers. After all, this was an era when computing power was heavy and cumbersome, as we've seen, so if that couldn't come to you physically, it would have to virtually. One of the programmers working on this remote functionality was Bob Thomas at BBN Technologies. BBN stood for Bolt, Beranek and Newman and still exists today as Raytheon BBN. But in the 70s were at the forefront of developing packet switching networks for ARPANET. They were actually responsible for providing the interface message processor, which allowed differing machines and operating systems to interface on the network. So, in 1971, Bob found himself tasked with engineering a resource sharing capability, allowing users to develop applications which could move to and execute on a different computer. The motive behind this was simple. If a computer in one part of the world was overloaded by daytime users, a task could be sent to a computer on the other side of the world or country at night and execute with much greater speed. It also meant that a program could be developed on one machine and then ported to another, much more efficient than moving vast amounts of unprocessed data from machine to machine. The resource sharing program that Bob Thomas created was written in PDP-10 assembly language and designed to run on 10x machines. It was given the functional name of RS-Exec, Resource Sharing Executive. However, RS-Exec was far from a full-blown utility. If anything, it was a lightweight application with one tenet in mind: proof. Proof that what was impossible before was now possible. The coined name for this pioneering worm was Creeper because it crept around the network. There was nothing malicious behind Creeper. The program exposed what we would call an application programming interface, which allowed a secondary program to package itself and ship to another computer to unpack and then run. Out of the box, it did this with a database maintenance program, which ran a few tasks on each machine. It didn't even replicate itself like a traditional virus. It didn't subvert an existing mechanism, it simply moved, or crept, if you will, of its own accord, and when it did so, it left no trace it had been there other than this simple, on-screen or printed out message. But it did what it needed to. It proved a theory, and in doing so, laid out a path for others to follow. The first of those was Ray Tomlinson, a colleague of Bob's also working at BBN Technologies and programming for the 10x operating system. He had begun receiving calls from various 10x sites asking what this creeper thing appearing on their system was and how to get rid of it. That got Ray's attention and he immediately got to work. By 1972, Ray had brought two R's to the table: replication and Reaper. In a 2014 interview, Ray stated, "I don't recall specifically why replication seemed interesting. I think I envisioned applications where one thing leads to another. For example, an application analyzes data that indicate the existence of additional data located elsewhere, so it splits off an alter ego to go process that data while the existing instance continues the analysis of the data in hand. In such a case, the application's instances would naturally terminate as they concluded their analysis, so capture was not necessary as long as there were no malfunctions." Ray had altered Creeper's code so that rather than removing itself from each machine as it went, it simply copied itself. It left itself on the originating machine and on the new machine. It now replicated itself like a virus or a worm. Software has bugs. For example, the application might fail to realize it had already visited a dataset and run forever, repeatedly replicating and jumping from site to site. Ray's reasoning seemed to focus on creating a scenario where software had failed to terminate after completing its function. A world of creepers might sound fun, but already Ray understood where this could lead. This possibility led to Reaper, which went looking for instances of Creeper to terminate them. In creating the Reaper program to search for and wipe out any instances of Creeper left running, Ray had inadvertently created not only the world's first virus, but also the world's first antivirus. Thankfully, nothing really could have got out of hand at this stage. No more than 28 machines could have been visited by Creeper, since that is the number of ARPANET sites running the 10X operating system at the time. In reality, Creeper wouldn't be described as a virus, even if it was malevolent. It didn't slip onto a system as a hidden package or tucked away in a boot sector. It was a worm, duplicating from machine to machine of its own volition.
Worm. A computer worm is a standalone malware computer program that replicates itself in order to spread to other computers.
But of course, Creeper couldn't be called a worm because the term worm didn't exist. It wouldn't exist for another 10 years in the wild, but it was actually coined in 1975 by science fiction writer John Brunner in The Shockwave Rider. Then the answer dawned on him, and he almost laughed. Fluckner had resorted to one of the oldest tricks in the store, and turned loose in the continental net. A self-perpetuating tapeworm, probably headed by a denunciation group borrowed from a major corporation, which would shunt itself from one nexus to another every time his credit code was punched into a keyboard. It could take days to kill a worm like that, and sometimes weeks. Here then is a world where people can use worms to their malicious advantage, to send them scurrying through computer systems, taking money, destroying credit, or doing anything else they were designed to do. A somewhat eerie prediction that, although already set in controlled motion by Bob Thomas, just like Robert Oppenheimer during the Manhattan Project, would soon become wild.
Using the term loosely, it's somewhat ironic that during development, Xerox's 820 personal computer was codenamed the Worm, as a symbolic reference to Apple, the Xerox being the computer that would eat Apple just like an actual worm, because Xerox also liberated the term worm straight from Brunner for a suite of software they rolled out in the summer of 1981. These programs could span individual machine boundaries and replicate themselves on idle machines in exactly the same way that Creeper had done 10 years prior. In an InfoWorld interview, Xerox were quoted as saying, "This idea is very powerful. What you really want to do is run a program that taps the excess computing power of 35 or 50 or 100 computers and lets you know when the answer is ready, and does it all automatically." Xerox actually tested 5 different types of worms in this period, the simplest of which had one job: to stay alive. Xerox developers John Schrock and John Hupp programmed it to appear on different machines, displaying the message, "I'm a worm, kill me if you can." They then tasked what they called an antibody packet to find and remove this worm, almost identical to what Bob and Ray had created some 10 years prior with Creeper and Reaper. But it's at Xerox where the controlled worm quickly got out of hand, and the first taste of what a malicious computer hopping worm could do hit home. One of the worms the Johns were experimenting with was called a vampire worm, which is perhaps as sinister as it sounds. This worm was designed to hide itself until human operators had left for the night before activating. Once activated, the vampire would parcel out large calculations to computers across the network before vanishing once more before sunrise. That could be pretty handy. However, one of these vampires had become defective and went on a killing spree. As it flew from machine to machine, it destroyed essential operating system data, leaving each workstation completely inoperable. So, as the Johns arrived on Monday morning to continue their work, they faced an unknown situation. They knew damage had been caused, but they didn't know the extent. They even suspected that the worm might have jumped through a network gateway to crash other Xerox machines in remote locations around the country. Thankfully, this wasn't the case, but the vampire did cause a lot of damage, rendering 100 machines unusable throughout the building. Thankfully, the Johns were able to use their antibody packet to track down any remaining segments of the worm and neutralize it. But this is perhaps the very first instance of a computer worm getting loose and causing actual damage. It may not have been intentional, but it shows how easily damage can be caused with problematic programming. By 1983, other computer worms existed, and with these, the problematic programming was intentional. One such burrowing beast injected into the UCLA system was called Pinball. It would sit on an infected machine for months before, out of the blue, throwing up the message, "Let's play pinball," before causing absolute on-screen havoc whilst simultaneously moving the hard disk heads back and forth like pinball flippers, erasing files as they went. Curiously, there isn't much information about pinball other than the odd magazine segment like this InfoWorld article by John C. Dvorak. More commonly known is the Morris worm, created by Robert Tappan Morris, and is often accredited as being the first worm to spread extensively in the wild. Written in Rex on the VM-CMS operating system, this self-replicating computer hopper first emerged from MIT, albeit as a decoy, exploiting buffer overrun vulnerabilities on DEX, VAX, and Sun machines. It's also the first worm to make use of widely connected machines on the early internet back in November 1988. An interesting quirk is that the worm will copy itself 14% of the time, regardless of having already infected a machine, thereby potentially mimicking the effect of the rabbit fork bomb almost 20 years prior. Along with boot sector infections such as Elk Cloner, written on the Apple II in 1982 by 15-year-old Richard Skrenter, this was the start of computer infections as we know it. And like it or love it, we're now stuck with it, particularly us Windows users.
But it's really Creeper, Reaper and the Vampire which led the way in malicious worm software. Without these tentative, sometimes problematic steps, the world of computer virology and maybe even the world of gaming may have been very different to what we have now. It's unlikely that worms such as Morris and Pinball would have existed, nor the slew of viruses which surged through the 80s like a leaking nappy. The BBN guys really paved a new way for programs to move across a network. You could be sitting there watching a video in blissful ignorance whilst a malicious piece of code is literally picking your operating system apart. And so, really, we should thank Bob Thomas, Ray Tomlinson and the Xerox guys because unfortunately, unlike examples such as the Morris worm, the Creeper source code is missing in action. But remember, this technology wasn't just used for malicious purposes. As an example, the methods used with Creeper were used in the McRoss air traffic simulator to allow parts of the simulation to move across the network, ultimately allowing control of a flight to move from one computer to another. Also, Ray Tomlinson invented the core functionality of email, for heck's sake. The @ symbol, the subject fields, all this stuff we take for granted, that was him back on the ARPANET. Thank God that email was never used for sending viruses then. Raymond! But these pioneers we owe a hell of a lot to, because without them, well, we wouldn't have the tech that surrounds us and we take for granted today. Until next time, I've been Nostalgia Nerd. Toodaloo. Raymond!